Hello, my name is Dr. Robert McDougall and I'm delighted to introduce Dr. Sarah Windsor, analytical chemist here at the University of the Sunshine Coast, who will take you through a series of experiment demonstrations, many of which you can complete from where you are. This work was made possible by funding through the Regional Universities Network grant for the DigiClassroom project and in-kind support from the university. The team working with Dr. Windsor today are video producer Chris Peckham and lab technician Mr. Scott Burrow. This is the sort of science that has a real connection for the way we need to think about the future in the thinking we do today.
So you saw in our ocean acidification example that putting the carbon dioxide into the water formed carbonic acid and turned our bromothermal blue indicator yellow. So what we're now going to look at is a consequence of ocean acidification. So what happens to those creatures in our oceans that have shells? So what we've got here is some calcium carbonate, and that's basically what most shells are formed out of. So what we're going to do is we're going to add our calcium carbonate to different concentrations of hydrochloric acid. So yes, we're not using carbonic acid because it would take quite a while and wouldn't look so good on film, but we're going to use hydrochloric acid today. So still it will show what's going to happen, a consequence of ocean acidification. So my assistant Scott here is going to start the timer when I add the calcium carbonate to the hydrochloric acid. So what we'll end up with is calcium chloride, so that's soluble in water, calcium carbonate insoluble, calcium chloride will be soluble eventually in the hydrochloric acid, and the time it takes to become soluble will be the end of the reaction, and then we'll stop the timer. Okay, so this is for the 0 one. We're going to start now and start. So I added 0.5 grams of calcium carbonate to 0 molar hydrochloric acid. And start. Okay, so we need to swirl, and Scott, you might want to pick that up and see if there's any left in there. Might need to give it a stir. So you might want to stop this timer when the reaction has ceased.
Okay.
Yep, I can't see any more calcium carbonate. So we had calcium carbonate and we added it into 0.5 molar hydrochloric acid, and you can see we end up with calcium chloride, which is soluble in hydrochloric acid, and our time is 41 seconds. So we can write down on here 41 seconds. Okay, so next on our list is our 1 molar hydrochloric acid. So I'm going to be adding again 0.5 grams of calcium carbonate, but this time to 1 molar hydrochloric acid. And we can start the timer now. Okay, you can stop the timer now.
33 seconds.
Okay, so you can see we had a decrease in time then, so 41 seconds for our 0.5 moles per litre hydrochloric acid, and then 1 mole per litre took 33 seconds.
Fresh one.
Thank you. So now the last thing I'm going to do is I'm going to add 0.5 grams of calcium carbonate to the 1.5 molar hydrochloric acid. And start now.
Seconds.
23 seconds. You can also see that no matter how much I stir the water, you can see that it's never going to change from calcium carbonate. There's just calcium carbonate in there. As opposed to having calcium chloride, which is soluble, calcium carbonate is insoluble. So it means our oceans, as they are, you can see that the shells can survive. Shells which are calcium carbonate will survive, but if we acidify our oceans too much, we'll have no shells left because we'll have calcium chloride which is soluble.